Guys, uh, I had a little bit difficulty to solve the problem. Like you guys can discuss level assignment level.
Yeah. Hi all. Very good evening to all.
Good evening, everyone.
Evening, ma'am. Evening, everyone.
Kanan, you can start like with assignment level. You guys can discuss among yourselves.
Okay, ma'am. So starting, actually, last week we started with assignment number 10, and thanks for the responses on the group, ma'am. That's very helpful on singularity and other aspects, including the sums.
Excuse me. Like in that assignment, I have one issue regarding the problem from 8 to 11. That fractography is there, no? Some problem related to that question.
Yes, Kiran, I remember the fractography question.
Yeah, yeah. Actually, that sir has replied to this thing. Actually, I didn't understand. Yeah, if anyone has that answer, could you please share it here so that we can see that I missed that.
Can you share the screen which what sir or can you tell what sir has replied so that we will try to understand based on that?
Yeah. Um, 1 minute. I will share my screen.
Yeah, that's fine.
Ma'am, I thought you had replied to these questions. I didn't know that sir has replied.
If it is from TA, it is mentioned, then other TAs, then if else it is sir only.
Okay, I thought you are the only team on this one. Okay, thanks, ma'am.
So I hope now you can see my screen, right? Hello. Now you can see my screen now.
Yes, we can see your screen.
Yeah. This is what the thing. Actually, I have requested sir like this.
Okay, dear course of admin sir, okay, could you please solve this as I can see many learners did mistake and your solution. What is the solution? Like, was it any different from what we got?
No, actually, I am not aware of this answer.
Yeah, Acha, this was a solution we got actually last time.
Okay, we got exact answer, sir.
Yes, yes, we got Kanan. I think so. We got same answers, right?
Ma'am, what I remember is I didn't note it down actually the answers, but what I remember the number of cycles was right, correct. And for other questions, whatever you are suggesting to include the magnification factor, that's also right as per this response.
Yes, like and then even the answers 0.4 into 10 power minus 3, 0.67 and 2 into 10 power minus 3. This also looks correct. We got this right and answer right, I guess. And then total number of cycles, can you go down a little bit? And then 11250. That is this is what we got, right, Karan, last time. Once again, let
Yes,
me
ma'am,
open.
around 42 or 43, yeah, around the same figure, yeah.
It's okay. Then, yeah, if you have this answer, can you please share it here? Not now, immediately, like after this.
I think so. I have uploaded YouTube video also
Okay,
regarding.
okay, I will check it.
I think so. I uploaded in week 6.
Okay, yeah, it's okay, man.
No, anyone else has any issue with this? Like everyone got the answer. I'll share my screen. Like, this was the answer we saw last time. So this was the answer we got. This one, and this one. And this is the answer we got total number of cycles actually.
Okay, 38,333. Yeah.
Huh. Was it falling
Going
inside the range?
41,937.
41,937. Maybe we might have.
It's not in the range, ma'am, but it's very close.
Yeah.
So correct. 0.67 is correct. Then what is the other one? 2 into 10 power minus. Yes, sir. Yeah, all those three are correct.
Can you share the 141,937? How sir got that 41,937 so that we will not make the same mistake?
Yeah. I think sir did in other method or for the length. Yeah.
Yeah,
Striation.
for length 3 to 7.5, the striation spacing sir has taken 4.4 into 10 power minus 3 given, and the number of cycles come acha sir has taken separate. Like we have done the same way, no, Karan, last time for length between. Okay, the average we have taken correct, and then similarly.
So 3 times he has taken this length.
Yes, we have to take 3 times. There are 3 different locations,
Yeah.
and from 3 centimeter, this one will start crack. The crack is from 3 mm, sorry, not centimeter, and from 3 mm to 7.5, the average spacing, sir told at 3 mm we have 0.4 into 10 power minus 3, and at 0.7 mm, I think so it was given in the question only. And oh yeah, I think so. Can you show the question once? No, the other tab.
Yeah. This one.
Yeah, so it was given at 7.5, 0.4 into 10 power minus 3 will happen. So much amount of striation spacing will be there. And that at 25, sir said 2 into 10 power minus 3 striations spacing will be there. And in between what we did, we took a average of that. But then we should have done at 12 mm also we found out using the answer, right? At 12 mm, so what we did in between 7.5 and then 25, we took the average of it. But then we have again at 12 mm. I'll share the screen.
Oh.
So what we last time did, at 7.5, it was before given 0.4 into 10 power minus 3, and at 25 it was already given 2 into 10 power minus 3. And then they asked to find out at 12, and then at 25 it was already there. So at 7.5 we got it, like it was all there, and then like how sir asked to include the 2,500 magnification or 25,000 magnification, we did, and we got the same answer. The answers were correct. But what mistake we did was in this range also we took the average of it, because zero point 0.4 was already given and 2 into 10 power minus 3 was already given. We did not consider at this point we have, so we have to take the average of this. So instead, last time what we did, we took number of striations in this region, number of striations in this region, and the number of striations in this region, 25 to 50, that we have 2 into 10 power. So that's why we got 38 into 333. But then we have already got one answer at this point as 0.6 into 10 power minus 3. So we have to take number of striations in this region and number of striations in this region by taking the average of it, which we got a complete, sir got around 0.58 or something. And then we have to take, and we have to calculate the number of striations in this region. And then here also in this region also we have to calculate by taking the average. And up to 25 sir asked, or up to 50 sir asked?
Yeah.
So that's what we missed last time. So as we have already found it before, so don't leave out that part. So I take an average there also between these two. That's how we get more number of striations. That means more number of cycles, 41,937. Else we'll get a little bit lesser.
Okay. Okay, then we'll move to this new assignment. Ongoing.
Yes, you guys can discuss, like Kiran, like now you're fine, right? Like you can see the previous
Yes,
video.
yeah, I will do it once. Yes, step by step, I will solve it once, and then if there is any issue, then I will call. I will contact you.
Yes, we can discuss here. Kiran, you can start with discussion today. It's fine. You can answer.
It's me, yeah. Okay.
Team, before that, I have a clarification in assignment 9. Can help me?
So the it will go like this. If you guys have done any mistake in the previous assignment, we can discuss here. If anyone has done right, if anyone has got them right, so it will be better if we discuss and then try to resolve here, so that we guys don't make mistakes in the exam. So when you guys have problem as well, others will help you out in those discussion when if they have got right. When they have got right, else we will try to note down all the problems if none of them got right, and then we'll try to get it solved somehow. If we can ask sir or the other TAs. Yes, Karan, you can start.
1 minute. This is on week 9, question number 14. Share my screen. Number 9. The sum is on the specimen, but I got correct in other many things, but on this one I got wrong. The effective crack length considering Irwin's model.
It is question number 19.
It's only effective crack. Whereas for the crack length, actual crack length in Irwin's model is correct.
Yeah,
So
for that I consider. For that I consider the same thing. If you can refer to our SARS, this one, right? simplistic model also we have to consider that A plus delta.
Here my understanding is the effective crack length is the actual crack length plus the RP, correct?
Yes. Yeah.
So that's how I got other effective crack lengths correct. But here alone, if I sum up the actual crack length and the RP using Irwin's model, it's not working out. For example, the actual crack length is 20 mm here, and the Irwin's model, the RP is 4.5. So 20 and 4.5 should work out 24.15. So I don't know why the range specified as 21 to 23. So if we take the example of simplistic model, it works out actually. So see here it is the plastic zone size in simplistic model is 2.09 and plus 20 is the actual crack length, so it will be 22.09. This is what I've given here. It's okay, but
good evening.
Good evening, Suresh. Is Suresh?
Yeah, yes. It's question number 19, is it?
Correct, yeah.
No, what is the doubt actually? Just 22.079 has come. Actually, that was my answer. It was falling within the range.
Okay, maybe I made some mistake. Actually, what I did is I was just telling that the effective crack length, we know that it is actual crack length plus RP, correct?
Yes.
And I did that for other questions on effective crack length. For example, if you take a simplistic model, the RP is 2.09, actual crack length is 20, that will work out to 22.09, which is it's close here. So this works out in other cases except in Irwin's model.
The formula was 1 by 2 pi into K1 by sigma ys whole square. That is for the RP, for the Irwin model.
That I got here. That is correct here. 4.15 is what I got here.
No, this is for question number 99.
See, question 19 is the effective crack length is nothing but the actual crack length plus plastic zone size, no?
Yes.
So that means 20 plus 4.15, right?
See.
This is where I got confused. Maybe
sorry to interrupt. Actually, for this effective, for calculating A effective for Irwin's model, the correction factor delta, it is taken as RP by 2. That is the plastic zone dimension 4.16 divided by 2, you get 2.08. And plus 20 will be 22.08.
Oh, is it by 2? Okay, I missed there.
There is a table in which the video sir has mentioned a correction for crack, a summary. So there is value of delta given for plane stress and plane strain for simplistic Irwin's model and Dugdale's model. So for Irwin's model, if you take for plane stress, that correction factor delta will be RP by 2.
Okay. Thank you. I didn't note that. Thank you.
No, actually, what I thought is if you can read that topic, that a small scale yielding approximations are there, no? Yeah, in that one, sir has mentioned that to calculate that effective length, we can take A plus delta. If you can refer to that small scale yielding approximations in that video, I didn't remember. So it is in week 9, first lecture.
You like to share the screen?
Lecture 29, Irwin's model. There is a small scale yielding approximation is there. Wherein third row.
If the region of plastically, if the region of plastically deformed material is contained within the singularity, Singularity dominated.
Three zones.
Yeah, the
Generally,
failure law of LDHM applies provided physical crack length is corrected as the same method.
Just that, I mean, just for the sake of, I mean, for understanding the concept, it's better to go to that Irwin's model video. But if you want a summary that is for problem solving, if you go to that lecture 30 Dugdale model, in the end of the, almost near the end of the class or somewhere middle, there is a table in which there is a plastic zone lengths, a summary, in which for simplistic Irwin's and Dugdale's model, it is summarized for plane stress and plane strain conditions.
No, if you go to this chart box, I have pasted those two pictures. Yeah, you go there. Yeah.
I'll stop share.
No, in this one only just okay. There is no option to look into the. Okay, it was the one that table.
Correct, exactly.
And for Dugdale approach, yeah, this is the one. These two pictures, if you can refer, then after that, you just read that small scale yielding approximations topic. Is okay, right? We'll go to assignment level, or is there anything?
Yes, we can go. Yes, thank you.
Yeah, like this I have written during fatigue loading of cracked specimen overloading generally. So it was there in so across the crack growth. Yeah, it was there in the pictures where Sar stored in his lectures. Effect of all of this 9 Yeah, from here I had taken. Then overload is a pulse of air and because no, it's showing is the recorded load. Is that correct? We'll go to next question.
I think yes, Kiran. We can move.
Yeah, for the next question, J integral can be applied to. For this also, I have answers which is in the textbook itself.
I think it should be oxide induced crack.
No, the other one, the other question. Yeah, you can read in this one, right? So it states that the same approach can be utilized for solving this nonlinear elastic linear, and it is considered to be very helpful to capture the mass of exhibiting elastoplastic behavior near the crack tip. So I chose this answer, but all of the above. How about you?
Yes, it should be all of these.
Yes, actually, no, this yes, all of this. I have the doubt. The first option and second option are absolutely correct to my knowledge,
Yeah.
because logically I took all of them. But third one, I am not very sure. Is it clear from this paragraph?
It is there. Right now we can read this one.
Okay. We can go to next.
Then the next question is identify the crack closure mechanism. I consider it as oxide induced crack closure.
Yes, true. That is correct.
And the fourth one is nonlinear elastic fracture mechanics can be extended to elastic plastic fracture mechanics. Is strain curve for nonlinear and elastic plastic materials is the same. I am not sure this one. I consider this will be the same in this case. I am not sure whether this is the right one or wrong. See, because why I consider this answer, I will show you. Yeah, if you look at this one, yeah, this curve is showing, right? It states this is for the linear elastic. But if you look into the other curve, right, yeah, it can be applicable for both non-linear elastic and elastoplastic. But I am not sure this is correct or wrong.
Actually, this option, yeah, the statement A is correct, no doubt in that. But only state and that second statement, the reason is only just I have a little.
Yeah, yes, correct. I think if you see the curve, it stops here, then the new one this right during non-linear elastic zone.
Sir, excuse me.
Yeah.
Hello. Yeah, on this answer, I have given option 3. I'm not sure. I have taken based upon the video lecture followed by sir. Sir told that for unloading the Stetson curve, when we have when sir handled the video lectures, he told clearly that for this one, for Stetson curve, for loading it's same. For unloading, for elastic, non-linear and elastic plastic material, it's not same. So I have taken option C. I'm not sure, but I have taken because of sir words, what I understand from video. He told that Stetson curve for non-linear, for loading is same, for unloading it is not same. So maybe for that purpose, I have chosen option C.
Yes, I was also having the same opinion.
Yeah, because I have not had any books PDF and all, but when Sir clearly mentioned, I don't know why that things Sir clearly mentioned that for 2 minutes about when unloading, it's not same. So I come to the conclusion that option C maybe because A is correct. Option B it's not correct obviously.
Okay.
So I have concluded with C as an option. I'm not sure.
It's okay. We will go.
In
Actually, I
that
am also not
opinion,
sure. Yeah.
because B say we can have a trial and options. We have 4 options. D cannot be. A is right, so B cannot be. Because B is wrong, so that I conclude option C.
Okay.
Can you share the PDF of this book?
PDF I did not have. I don't have that book.
It is easily available in Google. I mean, if you just Google it, Elements of Fracture Mechanics by Prasant Kumar.
Okay.
You will get it.
Okay. Then we will. Okay, that is
I
one
think
thing. You're
the
not
option C looks to be the correct answer.
What is that you are saying?
Option C. As per the graph, non-linear and linear, so non-linear and electroplastic, both graphs are not same. Okay,
Yeah.
Either for loading or unloading. If you consider both loading and unloading, they are both they are different.
Okay.
Okay, from this option C is correct. I feel.
Okay. So fifth question. Choose the statements regarding fatigue loading of a packet specimen. So I chose these two options. Overload retards the crack growth. Then ancillary overloading is highly beneficial for crack growth. I think it is in one of the lectures, I guess.
C is also correct. Reverse loading is less effective for crack retardation. That also I
Yes, C is also correct.
Yeah.
Okay, reverse loading is less effective.
No, yes, C also, option C also right. Reverse loading is less effective for crack. It's straightforward question answer only.
Okay.
The fourth option, because of smaller plastic zone, it should not retard, is it?
You will have a larger plastic zone, in fact.
Correct. If overload takes place, small plastic zone should be larger. It should not be smaller.
Larger, exactly. Correct. So it won't be the D is not correct.
Okay. Then sixth question, which of the following statements are true regarding nonlinear elastic material behavior and elastoplastic material behavior? Selected in nonlinear elastic materials, the loading and unloading path remains same. In elastoplastic materials, the loading and unloading paths are different. For elastoplastic materials, one has to keep on track of loading history for the stress transfers. See, it is, if you refer to the lecture number 3, but I think somewhere we are playing.
No, I am having a different opinion. This answer are right. In addition to that, A, B, C, D, E is right. E also right? We have two stress value for a single strain.
It's almost at the last phase.
So we'll have to understand what is the difference between non-linear elasticity and elastoplasticity.
Now you can have this audio also, no?
Animation
In this video.
I have this stress strain curve, and this is shown for a non-linear elastic solid. And up to this, there's no problem. When I have this portion is linear elastic and this portion is non-linear elastic. Suppose I unload, what would happen if it is a non-linear elastic solid? The unloading path will trace back the same way.
Yeah, 1 minute. Now if I go to this question, the same question, nonlinear elastic fracture mechanics can be extended to this, the stress strain curve for nonlinear and okay, this elastic plastic material is no. I think it's my mistake. I forgot that this is elastic plastic, right? Okay.
In a linear elasticity, you will go up and down in the straight line. In non-linear elasticity, you will follow a curve. Suppose I go to elastoplastic behavior. From elastic region, I have gone to plastic region. When I unload, the unloading path is different. It is not same as the loading path. This is a very key important information that you have to keep in mind. And what is its influence? When I have a nonlinear elastic curve, for every value of strain, you have only one value of stress. There is no difficulty at all. Now I do an unload. It has reached a plastic condition and I unload. The unloading path is different. And what is its influence? Suppose I take a strain value, two stress values are possible. This is a very key important observation, and this is where the complexity comes. When you want to go for plastic analysis, unless you keep track of the loading history, you will not be able to find out a relationship between stress and strain. You have to keep track of the loading history. I am in the loaded path. When I am in the unloaded path, for the same strain value, I have a different stress, and that is what is summarized here. You have to keep in mind, in elastoplastic, loading and unloading paths are different.
Now if I see this answer. Yeah. In elastoplastic,
He
loading,
also looks correct. No, this is clear.
loading and unloading paths are different. For one strain value, two stress values, need to keep track of loading history in elastoplastic.
For one strain value, two stress values exist. So you have to keep track of loading history. So this is where all your approximations come when you want to extend J integral for elastoplastic fracture mechanics. For nonlinear elastic fracture mechanics, J is same as G. You can also have this energy interpretation, and this system is conservative. When the moment you go to plasticity, system is not conservative. Some energy is lost. Whatever the graphical interpretation you saw, all that energy will not be available for crack extension. Some energy is lost in plastic deformation. So people have to bring in some kind of approximation. Let us see what are the approximations people talk about. So we want to graduate from.
Yeah, okay, this is the one, right? Now we got answers, right? What are you agree with these three, or what am I did anything wrong for them?
No, right.
Yes, yes.
Actually, I thought that option A, B, C, E also right, but it's for non-linear. It's non. It's right only. What you written is right. Actually, I misunderstood this non-linear elastic material. That is same only. One stain, because one stain value there will be two stress value for elastoplastic material. That answer. Yeah, your answers is right. I only make mistake.
This is B, C, and E. Correct?
No, your answers are right. B, C, and
Yes.
yeah, last option. That is fine.
Yes.
Three only. B,
We'll go
C,
to
and
next one.
E.
We'll go to next one. Lot of
Huh?
numericals are there. They may take a
Yeah,
little
yeah,
more.
yeah. Seventh one. Stay
Ah,
for.
okay. In this question, huh? So in this question, we have to identify uh, value of j along this path, right? So if you can read this book, he has explained very nicely, like in what way that we need to take, right? The same procedure we can follow. This is B, C, D, E, F, and H is there, right? So I to take only the place depth H. He has explained in this one. the chosen path BCDEF and it coincides with body contour. Segments CB and EF of the path geometry do not contribute to the geometry because DX3 is inaccessible and PH is zero. So I can just include exclude these two first of all, CD and EF. Then the contribution of the segment DE, this is the DE, towards J integral is negligible because the stresses are very small. So you can just ignore this one also, which in turn make W and PI negligible. On segments BC, BC and FH, W is negligible. No contribution of bending stress. 1 to 0 bending moment and negligible contribution of shear stress. So he has found out in this way. Then after doing all these integrations, everything and all, finally it came to the equation similar to energy.
This is the formula.
Yes, correct. Yes.
This is the reactive. But maybe my I have done this. Say I have used the same formula, but I have got a little other answer. Maybe my calculation maybe must be wrong.
Is that right? You got?
6-digit answer I got.
No, here if you refer, this is
it's 98.7428, right?
Yeah.
You have to take it in newtons. You have to convert it into kilonewtons to newtons.
Yeah, P value we need to take it as 12. E value we need to take it in Newton per mm square. Others are in mm. And load is given. Load is given in kilonewton. You need to take it in Newton.
Yes, I changed all this one to this method. Now you got this answer, right? So
yeah, it's right.
If you refer to this book, then you will find a lot of information.
Yeah, answer is right. I got 98.7424 something.
Yeah. Same thing. Then from here, the actual adventure will begin. In this one, yeah. So what they are saying is, Act was brought to service dock for periodic service. While inspecting the engine room, the quality assessment team identified a corner prop, the bracket made of ASI steel, which is used to attach the engine to the ship's body. The engine is subjected to tensile load due to vibration loading from sigma mean to sigma max. Given the character size A0, E they have given. So you can take this Paris law constant is given. So here my question is, yeah, if you take this track radius, right? I calculated by considering it as a corner crack. So for those things, we have an assumption 1.2%, right? That we have to consider, no, like this.
Correct. It will be 1.2.
Yeah. So to calculate this one, it's okay. But if you go back to this thing and to find the value of propagation light, we have one equation. Yeah. This topic you will find. Yeah. So this is the one. If you refer to this equation, it says that note that this expression is not valid for m equal to 2, and one should go back to this equation. Okay. Since our value is m equal to 3, that what is the constant value they have given. So if we see in this one, the only unknown thing is what is the value for f of k naught by w. Like how to consider that value? I sent this query in morning, so, but I am expecting the reply. I don't know.
I think you can take it as 1.2 only. Because,
Okay, the same thing only you are going to consider.
yeah. That's the configuration of crack. I also took it that way only.
Okay. Then I will do it and I will check the answer. Like, are you guys have done already this answer? Or I will note down and I will read it. What are the answers?
Can you show the formula so that I'll note down and I will try it.
And I can take just one screenshot.
Okay.
One, right? Yeah, you can.
Yeah,
take
one second. I'm taking screenshot. One second. Yeah, I taken. Thank you.
Yeah.
Acha, which is the one formula?
Yes.
NP is equal to which one?
A naught root of minus pi by 2 plus 1 minus AF, that is the final crack length, raised to minus m by 2 plus 1 divided by m by 2 minus 1. That large formula in the middle.
What is that answer you got? Anyone can.
So the 8th question I got 18.4 mm.
18.4 millimeter. Okay.
And 9th question I got. Wait, let me just see. I'll just come back.
Eighth question, some answer has come. Actually, I'm not able to.
8th question, you can use the formula that is K1C.
Voice was very low actually. This,
yeah, K1C is equal to 1.2 multiplied by sigma root of pi a. So
yes,
you can, we know KIC as the fracture toughness as 75 into 10 power 3 and sigma will be 260. And from there you can calculate AF, that is the final crack length. Somehow I got it around 18.4, maybe you also can say.
Now we see this answer is the one that I got. I got around.
Yeah.
The formula is 1.2 root of pi a into sigma.
1.2 sigma root pi a.
No, actually it's an error in this book actually. It's an error in this book. Okay. 1.2 sigma pi a only.
So you have to take the maximum stress value, which is 260 megapascal, and fracture toughness is 75, and you can equate it to find out A. A in this case will be the final crack length, because after the final crack length it will lead to fracture. No, so that way you can find out.
Yeah. That is one thing. The other one. What is
somebody was asking for ninth question. I got around 4780 as the total cycles, and if you divide by 60, you will get 8 days. I mean, round off. That NP value when you calculate from that formula, got around 4780. Maybe you all can check.
What is that? What you are saying? Okay, so.
No, that we see. Basically, we have to find out how many days the next service has to be done. Okay, so
yes, correct.
Yeah. So basically, we have to calculate the total cycles. Total cycles will be NP. So that NP. Yeah, NP I got around 4780, 4780 divided by 60 will 60 means it is operating 60 cycles per day. No,
Per
so
day.
divided by 60. Yeah, so you can round it off as 80. Sorry, no, 4780 divided by 60. 1 second. Oh, it's coming 79. So 80 days, huh? Let me just check.
That is 80 days you will get, huh?
Correct. Sorry, 80 days. Correct. But what I would like to request is that you can just calculate, because here this answer will depend on your NP. NP is that main thing to be calculated. So
Yeah,
I
again this
request
NP
that.
value, again same thing you have to put here, right?
Yeah, so because here the thing is that it is prone to a lot of errors. So we have to calculate, we have to put the formulas very carefully. Because, yeah. Sorry, because M is 3.3, you have to put minus 3.3 by 2 plus 1. So carefully, what I did is that you can also try this. You can just separately calculate minus M by 2 plus 1. And that value you can put it as an exponent for A naught and AF.
Okay. So in this one, my thing is this one f of A by W. I will take the value
You
of
can take it 1.2.
1.2.
Yeah. C will be 2.56 into 10 raised to minus 12 and into 1.2 raised to 3.3, because please note f of A naught by W raised to M, that M you have to be careful. So we have to put 1.2 raised to 3.3 multiplied by 260 raised to again 3.3 multiplied by pi raised to 3.3 by 2. So that it's very, what I find is that very easy to make errors. So we have to calculate it very carefully.
Yes. So again in the other problem, we know the value of this NP. So we have to find this A for A of F, right? And all other inputs we know.
Can you show me the question? We'll just have a look in that.
Yeah. What will be the crack size at the completion of 4500 cycles?
Yeah, so in that NP equation, you can equate NP is equal to 4500 and then calculate AF.
Only
AF
unknown
is
value is unknown, right? It is the unknown value.
Yeah, so that will give you an idea of, after 4000. That's why, what I got is that the final one, the previous question I got 47, I was telling, 4780. So this, here they are asking to do 4500. So you will get a value which is smaller than the final crack length given. That's the idea.
So you mean to say more or less
it will be lower than the final. Yeah, you will get a value lesser than that.
15-16 mm range, right?
Sorry. 1 second. Let me just see my notes 1 minute.
Yeah. What is your answer? Just tell us so that we will note down and we will check it.
I just opened my assignment sheet. Let me just. Yeah. I got 16 mm.
Okay.
For question number 10. So that 16 mm is a kind of a smaller value than 18. What is that? The final what you get, which is given in the question. Okay. Yeah. So the if the final crack radius is 17 mm, so we have to get a value which is smaller than that, because if you calculate NP, as I said, I had got 4780, and here they are asking for a lower cycle, 4500. So logically, we should get a crack size which is smaller than 17 mm.
Okay.
Okay, for eighth one, what is the formula that NP? What is the answer?
Eighth question, you will get around 21 mm AF.
It's for
see, actually, eighth one is that what is the critical crack radius? No, before breakdown. So breakdown, I mean, breakdown is like before fracture, complete fracture. So, so what we have to do is that they have given the fracture toughness, K1C is the fracture toughness 75 megapascal. Then you have to take the highest stress value, which is 260 megapascal. Equate that into this equation. K1C is equal to sigma root pi A into 1.2 or 1.2 multiplied by sigma root pi A. So you know sigma, you know pi, you know K1C. So calculate the
No, one second. I am having issue in that formula only. What is the exact? Say, can you pronounce it slowly?
no,
K1C.
it's print, yeah.
It's the 1.2 root of pi a into sigma, right?
Into sigma.
Root
That's
sig
No. This is yeah.
No, so your A will be inside the root.
Sigma. Yeah.
Okay, acha, because I taken a root of pi a sigma, so that I got different answer.
No, sigma will be outside the root.
Okay, thank you.
No, wait. I'm just sorry. I mentioned just 1 minute. I had mentioned 21. That's not correct. 1 minute.
It's around 18.4.
It's 18. It is 18.4 only. Again, I got confused. Sorry, because even my calculation, I had striked out a few answers and then got the final one. Yeah, so it is around 18.4 for question number 8, which you can calculate and verify. And question number 9, we told it is 80, which is like 5. I mean, finally we have to calculate that NP, the number of cycles it will endure, divided by 60 will give you the number of days. And question number 10, 16. I mean, I request you to verify.
Yeah, eighth one is 18. I'm getting same answer.
Actually, ninth one, what was the formula?
Yeah.
That showed that it's a bit elaborate formula.
Okay, okay. I think these things were not taught in that actually this particular video lecture.
Correct. Yeah. So the thing is, what I understood of this formula is basically that the formula is like there's a delta K factor. No, it's a difference of the stress intensity factor. So, so that is how this AF and A0 came into the picture.
Okay.
So
Paris law, that formula is dA by N is equal to, it goes, no? What is that? Yeah, so the concise formula is dA by dN is equal to the Paris law constant multiplied by delta K effective power whole power M. So that the expansion of this delta K effective is only giving you that elaborate AF, A naught power, M by 2 and all that. So that's the complete formula.
Okay. The answer is turns out to be 80.
Yeah, so you have to calculate NP, which I got as 47. Where is that? Yeah, 1 minute. Huh?
Yeah, that you told, right? It's
yeah, 4780. If you get 4780, then you will definitely get 80, because 4780 by 60 is 80. The main thing is that as I said, that you can just first initially calculate that M by 2 minus M by 2 plus 1 value and keep it aside. Then you can use it in this formula, because even in the exponent also it is coming. Then denominator also there is M by 2 minus 1. So you will get that m by 2 value as m by 2 minus 1 value as around 0.65. So that 0.65 in the numerator, it will be, since that minus is there. I mean, okay, how it came is that m is 3.3, no? So 3.3 divided by 2 plus 1. So that will come around 0.65. So this 0.65, you can keep it aside so that you can easily equate in the equation. Then F we know, F we found out in question number 8. We found out 18.4. So you can equate AF as 18.4. Then you can give the A naught as the initial crack radius, which is already given in the question. Then C will be, you can, C also I got initially confused because of the units given in the problem. But what I understood is that you can just straight away equate that 2.56 into 10 raised to minus 12 value as it is without any change. Then you have to multiply 1.2 raised to 3.3. 260, see, it depends. 260 is megapascal. You can, we have to be very careful with the units because, we should not meters and mm, you have to get it right. Here again, I would like to just emphasize because I had taken 260 as 260 itself. I did not do 260 10 power 6 and all because what I can, Kiran, can you just scroll down that this page?
Yeah.
There is a sample. Yeah, this sample problem you guys can just have a look. I had taken this as a reference. You can just go down here. Just yeah, some more. Yeah, so here this you take it as a reference. Yeah, here they have shown that NP calculation. Please note that the stress they have taken it as 138 cube. So 138, although it is in megapascal, they haven't multiplied by 10 power 6. I don't know why, but if somebody can find out later, it will be nice, because so that's how you get that NP value as 203 and all. So this, if you take this problem as a reference, it is quite easy to solve.
See, is F is 1.12. How you taken F equal to 1.12?
No. In other problem, it will be a corner crack.
In this case, it belongs to another type of crack. Yeah.
So edge crack, it is 1.12. So
Yes.
for a corner crack, it will be 1.2.
But our problem is not edge crack, right? It's
Yes,
No.
correct.
That's why we have to.
It's corner crack. The problem number 8, 9, 10 is corner crack.
Correct.
Yes,
Yes.
correct.
Actually, what I was saying is that you can use it as a reference in the sense.
It's an example. Yeah.
Yeah, because what I want to just signify is that here it's an edge crack. So your f of that function of a by w is 1.12. Our case, it's a corner crack. So we have to take 1.2. What I want to emphasize is that I had the same confusion. What sigma should we put it as 10 power 6 or whatever. But here, if you please note, it is, they have taken the value in megapascal only. So only if you take in that way, you will get a reasonable answer, because something very small like 150 or 200 is not the right answer. Somewhere around, let's say close to 4-7. I mean, yeah, you have to know that it should give a reasonable number of cycles, right? So just you can use this equation as it is. So if you can note, the crack lengths they have taken into meters. That's why you have 0.0031 and 0.2719 meters. Okay, but there is the stress value they have taken in megapascal as it is. So
maybe here that K1C, that is in that
K1C,
the stress intensity factor. K1C is taken in megapascals. Maybe both the denominator as well as numerator both were in megapascals. That is why I think he has taken directly.
but in the numerator there is, I mean, so KIC critical length. No, see, in the critical length equation, we have got the value that in meters, 0.079. But then in this NP calculation, I'm not sure, because
Okay.
that's what I was coming to. Because here, what I understood is that this C value, Paris law constant, that also has a unit which is given in that question. I didn't know that. So it is maybe to match up with the unit, is that maybe the reason why even stress is considered in MPA. I mean, I'm not sure, but I just use this as a reference of how they solve.
In this one, we will use the value of C, M and all. Don't check the value. Constant. Okay, now we got some idea on this one. And but other problems, right? I use the same equation to solve these things. Is the same with you also? What are your answers, sir? Yeah, so that we'll check here. My answers are there. Hello?
Yeah, I'm solving, sir. I will instantly reply.
No, no, it's okay. Just want to know these answers. Just to verify once.
Instead of verifying, you guys try to understand the mistakes you have done.
And yeah, again, it follows the same as in another problem also. See, again, it's a kind of horn crack. This is the radius. So in this also, they are asking about the radius only.
Yeah, similar formula, similar answers, right?
But I didn't understand why this they have given after the first 5 loading cycles itself. In this, you will also see if it was an edge crack. So we have to replace that factor 1.12 that we have to keep it.
Can you explain problem number 12 and 13, how you have solved it?
Same answer only I have taken. Sorry, the same equations only I have taken. Yeah, we can follow. It's an example, right? What I also did same procedure. Just 1 minute, I will be on mute. Sorry, I got a call.
So now I got my solution. I mean, what I did was 28.4. That will be the final crack minus initial crack difference divided by NF minus 5. Why I took NF minus 5 is because that A initial was discovered at after 5 cycles. So first itself, the question again is that we have to find out the final critical crack length or radius. So same thing we can do. K1C is equal to 1.2 multiplied by sigma C root of pi into AC. So you can put sigma max as 100 and solve for AC. AC you will get around 35 mm, 35.4 mm, somewhat around that value. Then you use this 35.4 value as your AF, that is final crack length for your second question. And you can try to find out what is the number of cycles. So anybody there?
Yes, sir. Jim.
Yeah.
Okay.
Yeah,
Everything
yeah,
went
yeah,
silent.
No, no.
Sorry.
Yeah, and one more difference in this question is what you have to note is that when you find out NF, right, that sigma value will be sigma max minus sigma minimum. So you have to take it as 90 megapascal in this
Yes,
question.
correct.
Yeah, in that when you apply in the formula, because all this is because of the Paris law, which says delta. It is all because dA by dN is equal to that delta K factor is coming, no? So that is why. So delta K stress intensity, delta K at the maximum stress, which is 100 MPa, minus at the minimum stress, which is 10 MPa. So it is easier to just, for the time being, you take the stress value as 90 megapascal and solve. Kiran, did you do that way only?
That is a strange. We have to consider, right?
Sorry?
Stress range.
Yeah, the stress.
Yeah,
Stress, no?
if
I
you
mean,
take this one, yeah. Max minus.
no. In this question, it's 260 only. Correct. In this question, the question number 9, when you solve, stress will be 260. But going to the second question, that cast iron question, since there is a sigma min and sigma max,
Yeah.
here you have to consider the as 90 MPa as the delta when you
Ah,
calculate for the propagation life for the failure. So that A initial will be A naught will be 7 mm. Na? So it will be 0.007 raised to minus 0.5 minus 0.0354 raised to minus 0.5 divided by 0.5 multiplied by 1 by 1.2 cube. 1.2 is the A by W factor. 1.2 cube multiplied by 90 cube multiplied by pi raised to 3 by 2 or pi raised to 1.5 multiplied by the Paris law constant 1.75 into 10 raised to minus 9.
yeah.
So, I mean, this is what I have written. Kindly, please, because as I said, we have to be very
Now,
careful while.
now, if you can just refer your answers with my one, we can just do one small verification.
Okay, 1 second. So, you can see the screen?
1 minute.
Oh, why is it not coming? Share
I
screen.
think now it's coming.
Okay, okay.
And then again you will ask.
Oh, again it's lost. Why is it happening that way? 1 second. Share screen. Start share screen. Start broadcast. Okay. Yeah. So here is now you can see.
Yes, yes.
So this is what I have got, but only if all of us can verify and to be good because.
Seems to be 11,35.4.
See, request all of you, the 12th question 13, since Kiran got different answers, since we both got different answers.
Yeah, I think yeah.
So we have to just discuss what factor we have taken. So, Kiran, just want to know.
No, actually, in my case, it is wrong. I will tell you, like in your case, that is correct. Okay. I will tell you. See, let I share my screen. See, like earlier, I consider that f of a by this one is
Yeah.
there, right? It's,
Yeah.
1.12 I have taken. It is wrong.
Oh, okay.
Now your answers are matching with my answer.
Okay, yeah. So another thing is that here, just since there's a difference with the previous problem, when we say dA by dN, dA will be 35.4 minus 7 mm, which I think everybody would have got as 28.4, and divided by dN. So dN, what I understand is that it is NF minus 5. If somebody could verify that, because why I took NF minus 5 is because only after 5 cycles we got a initial radius crack of 7 mm. So that is how I considered. Request you also to just apply your thoughts. Yeah, so since the question what they've asked is, what is the propagation life up to failure for this specimen from the initial radius? So we got the initial radius at 5 cycles, 5 loading cycles. So that is why I took dn as the nf minus 5. If somebody has a different view, we can discuss it right now. So that.
Thanks for sharing the knowledge. Actually, five cycles should not big difference or be significant.
Yeah, okay. Because I did not okay, because since that value, main thing is that our value should fall within that range, no. And what you guys would have noticed is that the range is very close in some of the questions. That crack length and all that, just by even 0.0 decimal, that value also counts. So that's why I didn't, because previous question I had some previous assignments I had some, because of my errors, when that decimal places even up to 0.0 10 to minus 2 gets converted, it's out of range, hence the answer gets wrong. So we don't know what is the range. That's why I took as NF minus 5. Main thing is that I just want to know whether that concept is correct or not, because that main thing is that understanding. Another advice or one tip what I can tell you from my experience is that this factor is there, na? A naught raised to minus m by 2 plus 1 minus af raised to minus m by 2 plus 1 divided by m by 2 plus 1. This you can just calculate it separately and just keep that value aside. Why? Because as you go progressively into the 13th question, we have to change that 1.2 factor into 1.12. So once you are sure that m by a naught values you have done correctly, then it's remaining is easy, because then you are just left with 1 by that stress intensity factor cube multiplied by stress cube multiplied by pi raised to 1 by 1.5, because it is 3 by 2, and multiplied by the Paris constant. So that way. Kiran, now you said, are you getting the similar answer, like 10?
Oh, yeah, yes, yes, I got the same answers only. Yeah.
Okay. That's a relief.
That factor was wrong. I took it in case of
Okay.
for an edge crack I considered, so it is wrong.
Okay, my doubt was, because as I said that dA by dN, whether
Yeah.
that value, that's what I was thinking.
Oh.
So one thing to be appreciated is that I think, see, with the 11th question, when we do with 1.2 as a stress intensity factor, it is 35.4. Whereas when we do the 15th question, when 1.2 gets reduced to 1.12, we notice that the critical length will be slightly larger as 41 mm. I mean, that we can appreciate that, but you can also check whether the value is correct. 41 mm. When you replace 1.2 by 1.12.
Is there any other things like to discuss apart from this?
So,
Old assignments also.
old assignment. Okay, maybe Kiran, you can
Half an hour.
take over, or somebody else can, because I have left J integral related questions, because I'm just covering the video right now. So, so I haven't solved that. That's why I just, yeah. Suresh, did you get the same answer for this?
Are you guys done? Can we stop the class or do you still want to continue?
Okay, man, I don't have much to say because this particular assignment I find it very tough. With, with help of some of my friends, actually I could solve some of the questions. Thank you.
It's okay. Like always, to discuss is very important. Like in the
No, particularly this numericals, no, it was not actually taught in the particular this, lectures. It was not the case in the previous lectures. This particular lecture only we find this particular week only I have this problem. Thank you.